Hello, hello. Welcome, welcome, welcome. This is 9.3, number 1. Now, what's going on here? Remember how way back in 8.1, we talked about if you were turned into gold, like a big statue of you, life-size, made out of gold, how much would the mass of it be? And we found out, well, I found out in my case, that this statue would be, well, more massive than my car, because gold is very dense. Well, guess what? This is how much you would have a mass of if you were turned into gold of the same volume, but I think there's a way to turn you back. But in order to turn you back, we have to get your body temperature up to the temperature, well, of a body. Gold is cold-blooded, it's basically room temperature. We need to get you up to body temperature so that when we change you back, you don't die of hypothermia. So, we got to figure out how much energy is going to be needed to get you that temperature. Now, the formula I love to use is the specific heat capacity times the mass. Obviously, the more massive you are, the more energy it takes to heat you up, times the change in temperature. So, let's start putting in some values to figure out how much energy is going to be required to heat you up this much. Okay, so now if you go back, you'll have to go back to 8.1, number 3, to find out the mass of yourself made out of gold. So go back and look, but you won't mind if I don't wait. You can always just pause it. You can pause it right now. I won't go anywhere. Just pause it and go look. Okay, you're pausing it? Oh, you're back. Okay, good. Anyway, so the specific heat capacity of gold is 129 joules per kilogram per degree. And I'm just going to double check that. Yes, it is 129. My mass was 2,112 kilograms. And the change in temperature, well, I'd have to get up to 37 degrees starting at room temperature of 20 degrees. So 37 minus 20 will be the change in temperature. How much I have to increase my temperature to get to body temperature so they can change me back into a real boy. Now, 12 times 212, or 2,112, is 272,448. Now, by the way, that's the amount of energy required to heat my entire statue up 1 degree. How many degrees do I have to heat it up? 37 minus 20 is 17 degrees, so I'm going to have to heat it up by 17. So let's multiply this. And what I get in the end is 4,631,616 joules of energy. Now, we can't really say for sure what our margin of error is, but probably only about 2 digits. So let's just say, can we say 4,600,000 joules? Or, if you don't like writing all those zeros, 4.6 megajoules. Now, by the way, a lot of people are using the lowercase m. That would be millijoules. A millijoule is an unbelievably tiny amount of energy. Maybe it's the energy that an ant goes through picking up a computer chip or something. It's a tiny amount of energy. We want megajoules. But you can just leave it in joules. That would be fine. Now, something else I might want you to think about. 4 million joules. That's not very much. In fact, most of us burn 2, 3, 4 times as many calories as that in a day. And that's kind of weird because remember, not too long ago, we figured out if you took your daily calorie consumption and you heated your body up, you didn't heat up much, did you? Well, on the other hand, we're not heating up much here. But yeah, it's not a huge amount of money or a huge amount of energy when you consider how much we go through on a daily basis.